Good morning, ladies and gentlemen. My name is Qingyan Chen. I'm the director of the PolyU Academy for Interdisciplinary Research. So I'd like to welcome all of you to this seminar. You probably know that PAO organizes seminars from time to time to invite the prominent scholars to come to PolyU to talk about their research, their achievement, and this is a very important aspect of international collaboration between PolyU and outside of the world. And today, we are very happy to have Professor Cao Shi-Jie from Southeastern University of China, actually located in Nanjing, come to Hong Kong. So I knew Professor Cao since he was a PhD student at KU Leuven in Belgium. It was a long time ago. And Professor Cao returned to China about 15 years, about 15 years ago. And he first joined Suzhou University, and then moved to Guangzhou University, and now he's in Southeastern University. So I can see from his career development really just jump from one place to the other place, but also academically, he now is a chair professor there. And very importantly, you probably know that in China, there's also so-called outstanding youth scholar, which is normally awarded by the Chinese National Natural Science Foundation, very prestigious. So this is just one step to become an academician, right? So anyway, he has a very outstanding background, and just without further ado, let's welcome Professor Cao to give us a seminar.
Thank you very much. And first of all, I would like to show my greatest appreciation to Professor Chen to invite me to join this seminar to give a talk regarding my recent work. Indeed, the first time I met Professor Chen is from Kobe in the United States, and then we thank you. Then we meet each other at KU Leuven, where I got my PhD a long time ago past, and against professors and Niu Jianlei, and also very great to see all the friends here after COVID-19. Thank you very much for very nice pre-introduction. And without looking at my resume, you keep everything in memory. I really appreciate that. And today I'm going to give a talk regarding urban environmental system. After going through the introduction of a pair group, I think the topic I'm going to give it today is quite correlated. So interdisciplinary research, and which is towards the goal of health, well-being, and sustainable urban development. The topic, urban environmental system, it's not just within environmental issues, but also correlated with society or the human behavior, or even economy. But I'm not going to give all of them today because I'm still learning, because it's also kind of very complex for me as well. So my background is from building environment engineering, but now I'm trying to tackle those very complex environmental issues, especially under the climate change. This kind of background, I think that's also the goal of our Paris group's research. So digital modeling and intelligent control, that's the technical, basically that's my background, which I started my PhD regarding numerical modeling, and now we are also doing intelligent control for building environment, or even for urban systems. Okay, that's very short background of my the title. Here I'm now working at Southeast University at the school, architecture school. Architecture school is very interesting school, actually. It's a mailing to I think it's for art as start when they start architects, they're always talking about the beauty and the arts of the architect design. But now gradually, I think all my colleagues or even all the architects, they are very moving towards into sustainable goals, especially regarding environmental issues, also the energy conservation or carbon neutrality. So that's a good opportunity for us as well to collaborate with those people. Also, the architecture school is also interdisciplinary school. So we have colleagues from a background of geography, from software engineering, from economy, from different or even environmental engineering, etc. So it's a perfect place for me to do interdisciplinary collaboration with them as well. This is a very short, sorry for Chinese, and that's my very small young group. I'm the oldest one. My colleague, Dr. Feng, he's also going to give a talk this afternoon. He's working on, the environmental engineering application for heritage also. So that's very, again, another dimension of a sustainable goal for heritage protection. So I'm going to skip this part, and I will leave this part for him. Those another two young associate professors, and Dr. Feng just got promoted to be a full professor. And by the way, sorry I didn't change that. And those are the postdoc. All those my colleagues, they are from different background as well. So why? At the very beginning, it's not because I want to do interdisciplinary research, because in architecture school, I don't know anything about the architecture design. So you have to do something, and when when I recruit some young colleagues or students, I had no choice. I have to take who I can recruit. Maybe most of them, they are from different backgrounds. So after all group of colleagues from different background, I have to think what can we do together? What can we solve together? So that's another kind of background. So the research target we are tackling is regarding sustainable built environment, and we are focusing on the low carbon solution, low carbon, and also the cultural heritage, cultural dimension, also heritage protection, also the the intelligent, and also the healthy and comfortable issues, etc. And there, the left column is all this kind of objects we are focusing, like regarding building, transportation, mostly regarding about pollution and control, also energy issue and human behavior and facility and urban infrastructures, etc. Also society, economy driven, environmental issues as well. All the technique and the techniques and methods we are applying is monitoring, sensing, also modeling, fast prediction. Also, that's I got lots of inspiration and help from Professor Chen as well. Also, the assessment. Assessment is not just for energy, also for environment, also for health. We are trying to research anything regarding for urban systems, human and infrastructure and urban elements, and environment and energy issues. But mostly it's anything regarding very the problems to reach sustainable goal. And those as the right side, those are four objectives or four directions. First is environmental modeling and digitalization and environmental planning and regulation. Not just for building environment control, but also for urban environment planning. I think the impaired introduction also mentioned we try to prevent and do some interventions to avoid all the complex issues, complex environmental issues. Also the environment, energy, society nexus, because we do care about environment, energy. Also, we do care about the people. We care about the urban pool as well. That's also very important direction we are working as well. So the outline of my presentation contains 4 parts. The first is background. So the keyword is the climate change. I think climate change is a very hot and urgent keywords and in globally, and anything we are working, we are think from the background of climate change. Climate change, mostly we are not so clear about the cause and the consequence of climate change, but certainly we are sure about climate change. Most partially, importantly, is due to the human activities. So due to the urban climate change and urbanization and high intensity human activities, climate change caused severe lots of climate events, such as air pollution and water pollution, heat wave, floods, wildfire, and tropical storms, and even also some disease, and also some other social problems like migration, conflicts, even the energy storage, agriculture, etc., etc. So there's the most prominent phenomenon of climate change is high temperature increasing, as we can feel like every year the temperature is gradually increasing. Especially last year in 2023, in summer, at almost half the North Hemisphere experienced the hottest summer last August, I think, I suppose August or July. And plus increasing level is still a lot higher compared to the mean global temperature contained, including both the land surface temperature and the sea level temperature. Near ground, the temperature, land ground surface temperature is increasing a lot faster. So under this circumstance, we have to take it very seriously. So that's the big background, especially if we look at you know for the urban system. Now there are this kind of group called urban poor, informal settlements. Almost I think 14 billion people, 1.4 billion people living, you know, say in these informal settlements, and under climate change events, this kind of background, and those group may suffer the most. So we can't ignore them. But those people, they are actually making great contribution to urban GDP. I think up to 35%, if I'm correct. So it's urban climate change events. It's not just environmental problem, energy problem. It's also social problem. We have to care about you know, energy equity and also the social equity, and we have to think the cheapest you know, the low cost solutions. Like Professor Wang Yuhong is spent lots of time and effort working on nature-based solution. I think that's a great idea. So it's very complex. You know, we are thinking a lot. You know, before I'm doing modeling, and sometimes I even don't believe the modeling can work, can solve the problem, or even engineering. So I'm thinking, you know, because the complex issues may sometimes it's due to you know, the environment itself. Sometimes can due to human behavior itself. So it's very complex. We have to think. We have to think what's the cause of those problems. It's absolutely human activity. So I'm keeping thinking, you know, what's the relationship between human and nature? What's the cause of those problems? I think most of the time, maybe we can avoid those problems. You know, for instance, you know, before we plan the people, or before we you know, the urban plan, we can certainly do this kind of quantify and rational analysis to design all those industry manufacturing center sites and residential centers. I mean, sites locations selection. I think we can do some like a rational analysis, and before we really plan the city, the urban system. But we are certainly we are not doing like that way. And also, like we human beings always are very, we are greedy. We desire more than we need. Then we cause lots of problems. Why there's pollution or like energy shock, there's lots of pollution or high temperature, this kind of environmental issues. Maybe it's mainly because of this kind of imbalance of energy and mass, of the nature cycle. So basically, as we human being, we are trying to change, adapt to the nature environment by developing the series built environments like buildings, transportations, or landscapes, and to satisfy our daily life, to satisfy our needs. But we need more than we need, actually. Yeah. Also to satisfy our production. We focus on economy. Because of the economy, like the city, the government, they care about the economy. If they don't care about the economy, so they control the number of population number, control all the vehicles, control the the development of manufacturers or industries. There might not be this much pollution problems, but of course they can't. The government, they care about the first target or the first goal, the priority they care is about its economy. So we have to think, sometimes, but absolutely we cannot ignore the importance of economy. But behind the economy, we also think what can cause, maybe for the next generation, we may invest more money or to solve or we cannot solve. So those kind of nature environment and built environment, they are due to a human intensified human activities. There are like mutual interactions and mutual influence. So we cannot analyze one part by ignoring another part. Like either building environment or urban environment issues. So I already mentioned it's because it is kind of imbalance of mass and energy, because we take mass energy from the nature. But we have to use this kind of mathematical way or or physical way to understand why there's this kind of imbalance happening. We are focusing on city. Our group at least focus because 56% of the world population now currently lives in cities, and generating 80% of the global GDP. And pollution in cities there are numerous sources, but those sources are correlated, and they are interacting each other, and also with dynamic activity. And also there those pollution media, they are transmitted from one to another. For sometimes air pollution can cause the water pollution as well, but I will give an example later. And also there's another very complex issue is uncertainty, because our desire is uncertain, right? Our demand is uncertain. So I think there are uncertainties, activities. Sometimes the government decisions are uncertain as well. So this can cause lots of as a difficulty to solve those complex issues. So I list lots of there are many environmental issues, but not just from one because environmental engineering, if I look at least in mainland China, lots of universities, they just equal environmental engineering equal to water pollution treatment. I think that's not right, because there are many things can be related with environment problems, like noise pollution, lighting pollution. Lighting pollution can cause can also severely impact on biodiversity as well. So why it's there, I already mentioned, climate change, human activity, also the biodiversity, those kind of issues can interact with each other and cause very complex issues. But so that causes difficulty to solve these complex issues. And the main reason is because those are CC are correlated with together. So we have to take all those issues, all those elements as a whole, because urban system is a whole system. And so all those elements, for instance, all those elements, they are correlated. For instance, infrastructure and building and transportation and all those elements. But most of the time, we are not so sure which element is playing the role, and what's the transmission road, and even sometimes we are not sure whether there is a risk or not. How to evaluate this risk? So we cannot just simply say we should try to reduce carbon emissions. Sometimes we should not be. If there's no risk, we should not forget. We should forget about carbon reduction. It's really depending. So that's what is so-called environmental engineering. We have to use this kind of systematic approach and holistic thinking to solve complex issues. There's very simple example, for instance, like the heavy metals generated from those manufacturers. Those heavy metals can be transmitted, spread through in the ambient environment, cause air pollution. But also, those heavy metals, this VOC, this can also sink into enter the river, water, or even the ground to cause water pollution or soil pollution, or can cause the food pollution. So maybe sometimes if you find the kids get some problem, the health problem, maybe it's not a medical issue. It's because of air pollution. We don't know. For example, I'm from the north part of China, in mainland. When I was little, my mother always told me, please, you should eat more fish head. If you eat fish head, you will get smart. We are short of fish in my region, Shanxi province. Yeah. Then when I was little, I really like eating fish head. But now, why? Now I'm living in Suzhou, and when my son, when he tried to eat fish head, I said, stop, don't eat that. There might be heavy metals accumulated in the fish head. That's true. Also some vegetables can be polluted, maybe because of polluted soil. So when there's a problem, health problem or environmental problem, we should not simply say this is due to one factor, right? We should understand what's behind the system, all the elements which could impact on this problem. We need to understand the roots. We also need to understand the risk. We need to find a way to assess it. There are so many things we are not clear. So we all researchers should, from different background, we should collaborate to tackle the problem, real problem. Forget about what background we are from. So most of the time, people will ask, "What's my background?" I said it's hard to say. Actually, from my bachelor, master, and the PhD, and I'm from different background, but always focusing on the environmental issues. So to summarize, to solve the complex issue, we should use this kind of systematic approach, holistic thinking, and we need to understand, the philosophy, the frame of the system. Sometimes we even don't know the elements. Furthermore, this is a kind of you can see this is our research guide. Most of the time, as a verb, we are working on the first step. That's the work I was working 10 years ago. We're trying to solve the environmental problems. We try to use either software or the experiments to find what's the environmental problem. to solve the water environmental pollution, water pollution, or air pollution. I think that's the very basic tactical goals. But we should also care about environmental pollution impact on human health. Also the social equity. We should care about all the people, because people, different group, or from different group, from different region, from different different backgrounds, their vulnerability are different when under the same environment issue, this kind of background. We should also care about economic growth, also cultural values as well. That's the second. We should strategically analyze what are those correlations. We should try to solve them at the same time. At least we should consider all those dimensions at the same time. The last goal, the final goal, I think this goal can bring all people together, not forget about the region, the city, the community, or even different country. We can collaborate. We try to solve the problem, or we should try to understand the relationship between nature and human. For instance, climate change. I think climate change, this kind of background, that's kind of global issue. That's under this kind of the background. So there's a Paris climate change agreement. So people from different countries, we collaborate together. So when we look at the problem, we should not just focus on environmental pollution or energy conservation. We should also think the driven factors behind the environmental pollution. We also should think this problem from different dimensions: society, economy, also the culture, also the human behavior, etc. So to solve the complex issues, we cannot just simply say we develop a new technique or new software or digital solutions. I think engineering solution cannot solve such complex issues. We have to think and develop very strategic and creative solutions. Maybe cannot solve the problem at the meantime, but at least we should try to find an optimal solution. Then creative and strategic, we have to think from a very basic concept and the first principle. So then I begin to think, what's the definition of ecology? Especially environment, what's the meaning of environment? I think environment is the relationship between human and the surrounding elements, not just physical elements. All the elements besides human. I think this kind of relationship is the environment. What's a system? A system is a kind of a group of interacting, correlated elements that they are working together and function as the whole element. We can see it's a system. So when we take the urban as a whole, as a system, we have to understand all those elements, how they interact with each other, what's their mutual interactions. What's engineering? Engineering is we are applying mathematics, physics, chemistry, or biology, etc. This kind of basic knowledge to solve complex reality problem, to convert energy mass from nature into some beneficial products to satisfy our daily life and production. So engineering is to help us to understand to understand the nature, especially energy and the mass and the mass transfer, like heat and mass transfer. It's kind of a way, engineering. But we are in this presentation, also my current work, we are focusing on environmental engineering, system engineering, this kind of methods. So we are the meaning is engineering technology. We are aiming at overall protection. Sorry, it's translated by my student. So overall protection of the urban environment, we have to use this kind of systematic approach and holistic thinking to seek the scientific and optimal strategy. I don't want to see solution. You know, sometimes we don't have a solution, especially for cities. There's no solution, no perfect solution, and by engineering at least. There's optimal choices of solution, but now we cannot solve it completely. Optimal strategies for balance the total and the partial benefits. The total partial benefits, I mean, economy, society, and the environment. We should take them as a complex system. So something like this. If we take this the goal or the problem we are tackling, environmental issues, there are many impacting factors. Sometimes maybe because of this factor, or maybe the sum of those factors. We don't know. Even sometimes there's no factor at all for now. Maybe next year, maybe 5 years later. For sustainable, we have to think not just the past, not just current situation, also for the future. We should predict. For instance, some colleagues working on new material or new energy. If there's new building material, maybe all, you know, the pollution can be different. Also, the energy source changed. There might be some new problem. So we have to understand what's the elements and what's the interaction between those elements, and what's the impact of the elements functioning on our targeting object. So how to solve these complex environmental problems by engineering, or by using scientific and this kind of mathematical approaches. We can think, or we can take the urban urban system as a function. There are many variables can impacting on the urban environmental problems. So we have to summarize or extract the scientific characteristics of this urban system. Maybe the first is multiple elements. We have to extract the elements expressed with mathematical way. Also the multi-skills, because you know, the mass or energy transmission can be from different skills, not just maybe sometimes globally or nationally, regionally, or from the city to the community, even to building. I think there are many colleagues working on building environment or building environment control impacted by the street skill. There are some students working on that as well. Also interacting between different media. I already mentioned that water, soil, air, waste creatures, and also from we should consider the different stages, not just for end treatment, but also we need to do the you know, the applying, also the maintenance management, and also the treatment. We should try to avoid treatment. We should try to plan it and avoid those pollutions and the problems, and etc. There are many characteristics, and we extract the you know, we extract the environmental characteristics. We try to extract the mathematical features of this characteristics. For instance, those are not all those elements. They are functioning on the urban system by non-linear. It's dynamic, and also sometimes they are, you know, integral variable. I think it's changeable. Also contradictory, also uncertain. Uncertain, I think that makes the things the most. That's the most difficult characteristic, uncertain. So we are now trying to build a function for urban. I know it's impossible, but we are trying. We are trying to build an urban function by using math and physics, and we are collaborating with people from different backgrounds. So to finalize our goal is we are trying to understand the mechanism and this kind of routines of different complex systems, their interaction between different systems and between human activity and nature environment. So the objectives can be those three, and human urban environment pollution prevention and control. And also we try to understand the onto the mathematical foundations, and we are trying to construct different models to reflect the urban systems. Also, we are trying to we are trying to develop this kind of platform based on the like AI and big data and smart technologies. I need because I think I have 1.5 hours, right? 40 minutes. It's already 45 minutes, right? I have 10 minutes left, but I should I thought it's 1 hour, but it's okay. Yeah, I will have to. So this is the basic technique we are using. I'm going to skip this part, and lots of students are working on numerical modeling. Some people are using AI-driven prediction. Each method has their own advantage and disadvantage. We are trying to combine them, and by integrating knowledge data event-driven modeling, so this modeling not just for we can do fast prediction, but also with basic physical principles we can explain. I don't know. Oh, yeah. So the challenge I already mentioned is sorry, it's yeah. We are trying to build this kind of framework to solve the complex issue by digital modeling and intelligent control. The first is the multi-source data integration by remote sensing and satellite monitoring, satellite sensing and local station monitoring. Also interaction mechanism, also the assessment methods, and also we are trying to develop and find out the optimal solution, regulation and control methods. Those three are the three challenges. How to achieve, we try to lightweight all those schema source big data, because we have lots of data. And most of the time we don't know how to use this data. Sometimes we are not even sure the validity of those data. And the second one is something we are focusing the most, AI-enabled fast simulation accelerator. This part I'm going to skip fast. The methods we are using. The first is the sensing and monitoring of multi-source data. Second, I think people are familiar from built environment. We are trying to use Navier-Stokes equation, not just solve air pollution, but also water and the soil pollution. In the past, we developed this kind of self-adaptive low-dimension models to reduce the simulation time to ensure the accuracy. Also, this dynamic reduced order model and linear model is trying to reflect the interaction between different, nonlinear elements. The first one, is about scientific monitoring strategy for air pollution, not just for indoor but outdoor. We try to use limited monitoring to reflect this kind of non-uniform pollution distribution. Also, the rapid dissimulation by we are trying to incorporating limited monitoring and fast prediction model to develop the faster than real-time prediction models. So the last one is AI-enabled fast prediction model for indoor environment. This part is mainly for urban environment planning. So we need to extract all the elements. This is we are developing. We have already developed adaptive attraction of urban environment element matrix. Also the assessment assessment methods. This part is for this can digitalize the AI platform to reflect indoor environment and also urban environment. The online data and control decision strategy. So the rest is some ongoing and some ongoing projects. Some we have already published into the paper. So I'm not so maybe some of them are not so sure, but I just come here to share our recent progress. Maybe some of them even not correct, but I just want to share. This one we have already published this paper. So the low cost deployment for the urban environment pollution. Because for city, like this is based on Guangzhou data, there are 22 stations. So I have some questions. So first one, where should we locate these stations? And what kind of parameter should we do monitoring? Because some environmental parameter, some environmental monitoring is very expensive. For instance, ozone, like PM 2.5. Can we use some representative like with low cost monitoring methods? So we try to understand the philosophy behind the environmental pollution, like transportation and green infrastructures, and to try to find this strategy for monitoring methods. Also, how to represent urban environment pollution by those monitoring data from stations. Especially, we want to control and find the problems. So we have to understand the pollution from the whole dimension of the city. This one is we are developing a model for water and for snow and for hail, etc. This one, we are trying to compensate the disadvantage of satellite sensing, because from satellite, most of the time it's just for one city, one data, and especially near the ground. But we are demanding the data for the whole urban areas. We need to understand, because from different region of the urban areas, the vulnerability under the high temperature is different. For instance, exposure from industry, but for residential can be different. But yeah, so we have to build the fast prediction models and for high dimension, high resolution models for the whole urban areas. So I'm not going to explain the details, monitoring and a coupled model development, and to develop a high resolution fast prediction model for urban temperature. This one is refined. This one is basically, we are trying to fix the model by input the relatively accurate boundary conditions. We choose this is called a refined prediction method. Mostly, we are trying to choose the most reliable boundary data from different satellite sensing. This one is assessment methods. We are trying to find the correlation between exposure, pollution, and infrastructure. For instance, even the air, I just give you examples. So if there's in some region, the pollution can be very severe, but if there's no people at all, no people at all, so the vulnerability, we cannot say it's is weak, right? So no people, no risk. We have to understand the human activity. So heating map, also vulnerability. For some developed cities, maybe pollution is very severe, but they have a very good infrastructure, medical system. So we can't see the vulnerability is very weak. So there's we have to systematically analyze the correlations. This one is very interesting, still ongoing work. I just want to show you the result, the findings. In Plateau region, the temperature is increasing. The temperature increasing speed is a lot faster compared to other regions. Also, the humidity is very increasing. So, can we imagine this in this region and those group, their living is based on the shaping and selling their lamb, and they are living in the tents. Can you imagine if there's a very high temperature, very humidity? They cannot live. They cannot. Maybe they cannot adapt to the environment. Also, in winter, it's very cold, extremely cold, especially in north part of China, northeast part of China. In winter, it's very cold, but in summer, it's hot. And the energy storage, if we consider energy storage and comfort and health, there's a problem. So are we ready to solve those problems? So then we did some analysis of air tightness for the whole China, and especially focusing on the Plateau region and tropical region and the extreme cold region. This work is in the third revision of Nature Cities, and this paper is focusing on the mitigation strategy for urban heat island. So urban area is very limited, but how to take the advantage of neighboring rural regions, how to plan and landscapes of rural regions. That's and what's the key parameters of landscapes by nature-based solutions to mitigate urban heat island. That's the key philosophy of this work. I think it's very interesting, and we found out we should try to avoid the landscape patchiness, richness, and also the diversity. Diversity is also very important, and the location is very important. So we should not expand the urban areas without any limitation, without any constraints. There should be some limitation. We also did a simulation of the heat to simulate the heat circulation and the convection from urban areas to rural regions. This one I want to skip the methods. I just want to see the conclusion. We did some prediction modeling and prediction of ozone distribution for the next 50 or 70 years. We noticed because of the low speed. We already mentioned in that prefer the speed is wind flow speed is becoming very slow. So BVOC generated inside the city may take the role compared to the VOC generated by human activities. And all this will stimulate the increasing of the ozone. Maybe in 2050, 2090, then the city may not be suitable for human to live anymore. But the results may not be correct, may not be accurate. But I think the trend tell us something we should prepare. The ozone pollution. We should not just see the particle PM pollution is decreasing, so we see the quality is good. Maybe go to water, or maybe there's ozone pollution. I think Hong Kong ozone pollution is very severe, I suppose. The next is some engineering project. We try to incorporate this kind of fast prediction models for online control for the building environment. Limit monitoring, and then we do fast prediction, and with finally to targeting at the built HVAC system control. I think the time is the time is up. Yeah, I will skip this video maybe. Yeah, we also developed some software, prediction software, and also some equipment based on this. And John is leading this project to develop this kind of monitoring, prediction, and control, right? And also the disinfection, this kind of equipment. We are involved with extensive engineering projects. We are very proud that our equipment has been applied by Winter Olympics in 2022. Also, the Qingyan, this is a pioneer project for low carbon, yes, a low carbon design. Yeah. This is for, I think this is also another project for building environment control, right? To targeting at environment control and energy conservation. Also we are also developing this kind of platform for water quality sensing and control and a river. And this is this project again is led by Professor Feng. This is platform is used for Hunan Changsha province, mainly for lake and river, the quality water. To summarize, we should keep thinking the nature between human and nature. We should the relationship between human and nature. We should we should not be too greedy. For instance, we should focus on our human behavior. Sometimes very simple human behavior can solve the problem. For instance, there are so many people working on food waste management, but we are wasting lots of food. We are wasting too much food, maybe because of not necessary reasons, right? Like culture. Because in my hometown, my parents always say, when you invite guests to coming home, do not let the table, there's leftover on the table. Otherwise, you don't, that means your hospitality is not good. But I think it's wrong. And especially for now, I think it's wrong. Maybe this culture and also over packaging. I think that's another issue, right? Over packaging. Sometimes I just like a box rather than the gifts inside. Yeah, thank you.
Oh, thank you very much, Professor Cao, for a lot of information you have presented. I think if you have a time, probably you can talk for hours. So now we'd like to open the floor for questions.
Thank you, Professor Cao, for the very informative presentation. And I have one question. You mentioned the BVOC, right? It's perhaps generated by plants. Related. Have you considered that maybe different plants, different tree species, they have a different potential of generating this BVOC? Okay.
We started this project from last year. It's still ongoing. We are trying to, and the first time our ambitions to tackle for the global ozone generation and evolution, but now we're focusing on China. But still, it's very, very difficult. We first extract all the trees, also green infrastructures and manufacturers, transportation, etc. Because there are lots of factors impacting on the ozone generation. When we use Wolf CM code, Wolf, yeah, that software to simulate ozone generation.
Okay.
Yeah.
Thank you.
Thank you.
Thank you, Professor Cao, first of all, for your presentation. So I do would like you to elaborate on a project on the, I think the temperature prediction of the urban environment. Yeah, and you mentioned so did your group predict the temperature of the surface or like the air temperature?
Air temperature. Air
Okay.
temperature. That's the problem. We are trying to. That's not the. That's the target. No. Because most time we get the data from a temperature from the land surface, but we are trying to understand the distribution of the temperature for the whole entire cities. We try to understand in the correlation between different elements. We try to find the prevention strategy for the climate for heat wave. Yeah, also exposure from industry.
And so a follow-up question would be if your goal is to predict the air temperature and the surface temperature is kind of like an input to your model. So how was the surface temperature obtained? Because from my understanding, if we directly
Remote sensing.
Yeah,
Data
from
from
the
satellites. Yeah.
Okay, so that means the resolution is kind of like compromised.
That's why we need to incorporate all those the data as as inputs. We developed numerical models because we cannot get exact boundary conditions. Yeah.
Okay, thank you.
Reviewers always ask us this question: how do you input the boundary conditions?
The following question: why don't you use the weather data from the meteorological stations? I think they have the data, right?
You mean how do I get this data? I'm
not only from the satellite. I mean, they have the ground data.
Yeah.
The stations.
The station. So you mean how get data from the station?
No, I mean, in addition to the satellite, right?
Yeah.
You can also get the data.
Get data from the stations. Yes, yes.
Any other questions? Now, in between, I really wanted to ask you a question about interdisciplinary research. And from your background, you've been shifting from one field to another.
Yeah.
And today I learned quite a lot. Now you are more or less in the environmental engineering. It's really a bigger surprise to me because at the pair, we try to recruit the pair young fellow.
Mm-hmm.
Okay, it's a very prestigious position, but we ask our candidate to really shift from their original research to a new field, just like you. And we have gone through 2 rounds of recruitment, and we only get 1 very brave guys. So I just wonder what really, make such a big decision to change from your original field, because everyone feel very comfortable by staying their original field.
Yeah.
When you shift from indoor to outdoors, I think it's a bigger change. You share with me your experience.
Yeah, I think first of all, if you want to, you want to do, everyone wants to publish big journal paper like Nature or Science. If you look at their requirements, they don't care about, the main focus or the biggest requirement for the Nature journals breaking through or insightful findings. Breaking through and insightful findings, we have to jump out of our comfort zone. I think that's also they are focusing on the research goals should be much multidimensional, not just focusing on the one issue, one dimension like an environmental issue, also society or technology, and they try to let all the published papers to attract people from different background, like government, practice, also industry, also engineers, all even the public. So it has to be multidisciplinary. If you get a big paper, I think you will get lots of good funding, good job. I think it's correlated. It's for me, like why I get distinguished young scholar, because I'm working on multidisciplinary research. I think that's also the main reason.
But it's very difficult, right? I mean, if we take your research as an example, if you just solve Navier-Stokes equations, that's pretty easy for you because you are doing that most of the time. But now, if you wanted to develop like equipment, right?
Yeah,
it's a completely new one. How do you dare to work on a new one? And then it's harder to convince like a National Natural Science Foundation to give you money because if I'm a reviewer, I would say, look, Professor Cao, you have no knowledge on experimental equipment. How could you make this happen?
I think it's, again, it's because of your ambition. The equipment, we actually from the first initial design to the final product on a 1 month. We started from scratch. We have no experience of anything of equipment. Even the designs, even the shape design is developed by my students. We work together, collaborated together. My students are from different background. I think John, we can write. We have all my students and colleagues. Most of them they are from different background, so that makes this thing happen. Because we got a chance. One industry they support, they give us financial support. They are expecting the product within a short time. I think the motivation comes from the project, also comes from the young people, the ambition of the young people. We are from different backgrounds. Actually, we are not afraid of anything. For me, I think if I have funding, have a problem, I want to do anything, even biology, medical. If I don't know how to do it, I can collaborate with them. I'm not afraid of that. We are focused on problem solving, not the background.
Right. Well, thank you.
Yeah.
Other questions? Please.
Thank you, Professor Cao, for the presentation. You mentioned that the device to measure ozone or PM2.5 is relatively expensive. And you also mentioned that you designed some new device. So my question is, can your device to measure ozone or PM2.5, sorry, and are they like cheaper than the device that we can buy? And
Yeah. Thank you for your question. Sorry, I didn't make myself clear. It's not because our device is cheaper. We are not working on sensors. It's because of strategy. We are trying to scientifically deploy those sensors. We are trying to use the strategy to reduce the cost. For instance, for instance, if there's strong correlation between ozone and the particle PM10, maybe if PM10 is cheaper, so you can use PM10 to stand for ozone monitoring, and also we can reduce the numbers of monitoring sensors. That's also kind of a low cost sensing strategy. There are many. This can also the location, location, because sometimes I don't believe lots of paper, lots of work. They say the pollution is like this, like that. If you see if there are strong correlations, so NO2 strong correlations or NO2 between different stations, that means you just need to monitor it once, not twice. Locations and numbers, and also different the correlation between different parameters.
Yeah, thank you for the explanation. And that also brings my next question is about the proxy. So you mentioned maybe we can find some like alternative parameters to represent PM2.5. And I saw some publications, they mentioned that CO2 is like a common proxy for the indoor air pollutants. And what do you think about this?
PM2, you mean use PM2.5 to represent CO2?
No, the
The
other way
other
around.
one, the other way around, yeah. CO2 represents PM 2.5. Actually, I don't know, but it really depends on the background and the problem you're solving, right? It depends on source, what kind of environment, what kind of building environment.
Like the
You mean the building for residential building for housing?
yeah, the normal indoor environment like classrooms or
See-
office.
see, I think CO2 is mostly correlated with human, right? But the particle can be from outdoor, from indoor, from human activities. I think they have some correlations, but I don't think you can just simply use CO2 to represent the concentration of PM. That's my personal thinking. Yeah.
Okay, thank you very much.
Any other questions?
You were talking about the using remote sensing for measuring surface temperatures and then accounting for modeling onto air temperatures.
Yeah.
Yeah. How much is the remote sensing temperature data influenced by hotspots on buildings? So
Remote,
like glass that's directly in sunlight, air conditioning units on the surface of roofs of buildings that are at 50, 60 degrees Celsius. How much are they screwing around with the results and causing problems?
yes, maybe I didn't get your, so remote sense data impacting,
Yeah, you said your remote sensing data for the temperature
yeah,
of a city is based on the surface temperature.
yeah, based on surface temperature, yes, yeah.
So that surface temperature is going to have peaks in it where it's reading hot items.
Yeah.
Air conditioning units on roofs, solar panels under direct illumination. That's going to produce spurious results and peaks. Are you able to account for that at all?
Yeah, I think that's the reason why we are trying to develop this kind of dynamic model, because you cannot just using one data and single data to represent for the whole, the phenomenon like the hotspot. Like, so I agree with you. We cannot, but so that's why we are trying to develop this kind of dynamic model, prediction model, just taking the satellite data as kind of our also the gas station. I think a gas station model monitoring data also a kind of input for based on AI modeling. Yeah, I agree with. I think that's not a question, right?
I was asking if you'd.
Yeah, I think that's not a question. I think that's the reason why we are developing model. I agree with you. Yeah.
A couple of quick. What resolution is your remote sensing?
Remote sensing, I think, so 1.5 kilometers, right? 2 kilometers, I think.
That's your resolution.
Resolution. That's for satellite, but for our, I think, it's 500 meters, yeah, or even yeah, depends on the efficiency, yeah.
Are you taking into account time of day during the data?
Yes. Yes.
You're getting multiple.
Yeah, we do so that's why we are using AI training to increase improve the efficiency.
Is it low Earth orbit satellites you're getting from, or geosynchronous?
Sorry?
Is it a low Earth orbit satellite you're getting data from, or a geosynchronous satellite?
I'm not really but I'm not very sure about it, because it's for my PhD student. I need to talk with him, because also this is the first, I think, let me see. He used many, he got the data from different satellites. I think here also he's trying to compare. I forget the name of the satellite centers. Yeah.
All right. Thank you.
Hello, Professor. Thanks a lot for your presentation, and we learned a lot from your presentation. And one question is about your prediction of the temperature in the urban area like this. I'm wondering is how many weather station did you consider in your data-driven process?
weather station.
Yeah, weather station. How many weather station? Because you consider the area is very large. So I'm wondering. I'm wondering, is your weather station? How many weather stations do you consider in your data?
Yeah, if you ask me these details, this work is still not published yet, so I'm not. I'm not I'm not. Yeah, I need. Today, I'm just going to share the idea of
Okay.
what we are working. But if you ask me these details, I need to talk to my students.
Okay.
Yeah.
And so because so what kind of weather station do you consider? Because there are many kinds of stations in the city. For example, it was developed by the government or by the personal
government.
by
By the
government.
government, yeah.
So
We're collaborating with meteorological the government the department.
okay.
Yeah, we can get data from for all, the whole China. Yeah.
Okay. So for the detailed information, maybe we can discuss
Yeah,
later. Thank you.
Yeah.
All right. I think time is up. Thank you again, Professor Cao. Please give him another round of applause. So to express our appreciation, we do prepare a nice, I hope it's a nice gift for you. And I also wanted to thank all the people who asked questions here, and also thank you for your attending. You know that the pair organizes seminars, distinguished lectures from time to time. So our next lecture will be in August. Will be by Professor Huang Yuangang from Northwestern University in the United States. Professor Huang is probably the most famous scientist in the United States. I mean, Chinese scientist, because he owned the most of the titles of academicians, like U.S. Academy of Engineering, U.S. Academy of Science, U.S. Academy of Science and Arts, the Royal Society, the Royal Academy of Engineering, Chinese Academy of Science, etc. It's too many to mention. So I hope you will join us in August. Okay, thank you very much.